Nice. This is a bit low angle. Yes. Go Shack Attack. Okay, good. I really gotta set my backgrounds up. Well, it was a nice weekend. I did a lot of fiddling with the bot files that I have. So I don't know if I've even shown it on stream. Watch this. I have to navigate first to the location. Right here. Yes. I don't think there is a Tmux. So if I run this, it's I'll show you the code. So basically, it receives a directory as an argument, and then it starts a asynchronous stream of reading files in that directory. It reads every file into memory with 64 at a time. So prefetch queue is 64, and then it's like queuing. It's like prefetching the files into memory as a stage in a pipeline, and then this is decoding the file using the bot file decoder on a separate thread, so multi-threading enabled, and it pipelines that according to how many CPU cores there are, so 16 cores on my server, and then it like gets all the state back to single threading. So this is a single threaded function that is just accumulating. And so I just accumulate the results into this state, and then the return value is the state, and then I just print the final value. And so the accumulate function is adding one to the count. So like, oh, another file happened. We're finding out how many times people jumped in their recording, finding the duration of the recording, but it's there was an outlier, which might be interesting to look at today. And then I'm also checking to see if they're changing their settings after the run started. Just some random stuff. So that's like running highly parallel for lots of different things. Watch this. So how fast do you think it is? This is running in real time. We've already read 10,000 files, and now we've read 20,000 files. Yeah, it's quite fast. There's actually 1.5 million files. This would only take 10 minutes to run, but I've already run it. There's 46 million jumps, recorded jumps total. The Bhop game saves less than 1% of bots, of players' times as a recording. So of the recorded times, there's 46 million jumps, individual jump sounds emitted. And there's only about 2 years of recorded playtime. That's all. But yeah, this is already a pretty large amount of data. So like less than 1% of bots recorded, it would be 100 times more expensive. I could not afford to store this data. If we recorded every bot. So that definitely makes me worried for the strafe client. Oh yeah, I made this better. Cause like for the strafe client, I want to record everything. But oh my god, I love Shack Attack. Yeah. So I was thinking we could have like a distributed system where there's multiplayer servers, and every time someone gets a time on a server, every other play on the server saves it to their hard drive, and then now we have like distributed storage. um, yeah, I would need like a signing system where the player would like sign the final state or something. Something. And they would like I need to like make sure that the recording actually came from a specific player and have some sort of chain of trust. But then you could have distribute. It's kind of a bad idea. It's like a lot of work, but like it's to get around the problem of we don't have enough storage. So basically, if there's a map update, this is the idea of calculated leaderboards, right? Computed leaderboards, where if there is a map update, what? Why is it? Oh yeah, that's right. I was being stupid. Uh, if there's a map update, then what happens? It can take all of the bots for people who join the game and recalculate whether they can complete that map. So basically, if you join the game after a map update, the game would like siphon the replays off of your computer and rerun them to recalculate your times. And if you never join the game again, your times are lost unless I implement this like multiplayer server idea where like it just stores everyone else's times. Whenever they get a time and you're in the same server. It's very much not a perfect system. I would need some sort of accounting and balance it. If I wanted to like have it like robust, it would need other things. But like that way I could also have like distributed compute for recalculating those times. Although there is the problem of like faking it. No. The recalculation isn't actually that bad. I calculated that I could do it on my computer in like a reasonable amount of time. So I think it's not that bad. The real problem is the data storage. So getting the size of the files down is the biggest problem. And I can probably make the files uh, like 10 times smaller than the Roblox files because the Roblox files have all this position information, but the Strafe client files, it's basically only mouse movement. And so I do want accurate timestamps. If I can like get the delta encoding very good, and I don't know about 10 times smaller actually. The timestamps are pretty big, but like I could, how many pixels? I could probably get the mouse move it down to like 2 bytes or something. Yeah, it's kind of like a variable length integer problem because like you can have very big mouse pixel jumps where it's like 100 pixels. Three bytes? Yeah, that's really the main thing. But the problem is that like I would need the files to be like 1,000 times smaller if I wanted to. I'm just gonna go here. I need the files to be like 1,000 times smaller if I wanted to store everything for the Strafe client with the same volume as Roblox bhop. And it's not that compressible. There is a like sort of fundamental level of information that the file contains, and it can't go any lower than that. So I think it's about 10x smaller. At best. Which like, that would be hard to host 100 times more information, and like it doesn't make me any money. That'd be a tough ask. Yeah, it'd be petabytes of data. Not good. You know, I would definitely need. Wait, no, but right. Computers are so fast. There's a lot to think about. Um, at the very least, each player should save their own times to their computer, and then maybe re-upload them. I was trying to think of like um, how do you sign a file in a way which proves it came from the past, and you can't. You just can't do that. I guess I could. What if I gave out 2 keys? So I could say, um, your signed file is no earlier than this. Give away a key. The client, I guess, the server gives a key to the client. The client says, "All right, I'm signing the file," and the server signs it again. So it knows that the file was signed in between 2 server signing timestamps. Why didn't I think of that before? So then you can resubmit a file with the same signature. So you have a signing database that is 1,000 times smaller than the bots. Even 10,000, 100,000 times smaller. What is that? So it's like 100 kilobytes. So if it was 100,000 times smaller, it'd be 1 byte, but it's 1,000 times smaller. It's 128 bytes. No, 128 bits. It's 16 bytes. So it is 10,000 times smaller. Oh, that's kind of like the times database size. So okay, so the signature could go into the time because the time uniquely refers to a source of information. Well, okay, so it would no. I would want it to be the other way around, where it's like a big ball of original data, and it's like this run happened on this map in this physics version kind of thing. And then you have the hash. I guess a hash is good enough because you don't need to sign it a bunch of times. A hash is good enough because it bounds the time backwards. Yeah, so you can't resubmit a run. I would need to do some. You could you would okay. It's hard. Resubmitting runs is hard. Yeah, no, I definitely need a no. Yeah, it's so my idea, okay, so think about this. Players could just craft their own task files and submit those as if they were real runs. That's I think that's about where the stage of cheating is in Roblox Be Hot. But it's tough because it's non-deterministic, whereas with Strafe Client it is deterministic. So if you craft a run that reaches the end, you have a valid run. You don't need to like submit it multiple times or something to like hit the RNG. My idea to combat that is to have task leaderboards where the purpose is to craft these task bots, and they're like competitive spirit is directed at that leaderboard instead of like trying to like pretend that you're a really good player by submitting a task. You can submit a task and compete with other people making tasks, and it's sort of an easy way to be honest while still cheating. It provides a path of low resistance where you can expend energy to cheat in a controlled way that doesn't disrupt the non-cheating players. And of course, this is sort of a gentleman's agreement. And if someone just takes one of the task times and submits it to the normal leaderboard, oh wow, you got number one. But hopefully, it should be pretty obvious in the session data, because like if you're recording the session and yeah, so I think that crafting a session is harder than crafting a task, because you have to make the session look like you actually tried. And that's a lot of like real information. You could probably just do a straight statistical analysis of inputs on a session, and it would just have wildly different distributions if it was fake. So when you submit a time, you also submit your entire game session. So that includes all of the previous attempts that you did before you got the world record. And so it's sort of like, it makes moderation, like it's, you sort of have proof that you tried hard, rather than like the time just existing in a void and you're like, all right, here's my time. No, it's like, here is the weeks of practice that I put in, all of my previous failures up until the point where I got the run, and you can actually rerun the session and reproduce the run exactly. Oh God, I've been yapping so long that my screen's turned off. Oh, I hope that the screen recording is still working. Yeah, okay. So something I'm thinking about doing early next year is bots v2. So I just finished making a codec encoder, bots for bots v0, proof of work taken very literally. Yes, yeah, it's sort of manual proof of work, but maybe there's some statistical analysis you can do as well to immediately spot outliers of like, whoa, that session's not real. Because like if you log in, one shot the world record and then log out, that's pretty obvious. And you have like no history, right? It's pretty obvious. The main difficulty here is data storage. This is petabytes of data, and I don't have that kind of money. The game doesn't generate that kind of money. But it also doesn't scale, right? Where if it did generate more money because it had more players, then there'd be more times. So like the proportions are still off. It just will never generate enough revenue. So I need some sort of either distributed storage where the players are saving their own times, or just not save all times, and time wipes are the calculated leaderboards are just a bit sparse, like they are in Roblox. Before I get to that, though, I have to actually write the physics, and also I want to make a tool for the maps website where when you submit a map fix, you can preview the times that will be deleted via anti-cheat. So if you add an anti-cheat zone to the map, it should be able to just kind of trace the path of every bot and see if it goes through the anti-cheat zone. That shouldn't be that hard. Of course, I'll want to actually have the physics be correct to do that. I guess the access align bounding box, the BVH kind of makes it the trustworthiness of the BVH, the find to nearby parts thing, makes it so that even if it was like dead wrong and it's like, oh yeah, you're touching, and it's like not even close, it doesn't even check unless you're close enough. There's also the matter of path tracing. So I could check like each game tick to see if you're intersecting the part, or I could check the path between each game tick to see if your path goes through the part. But there is the problem of teleports. Like, I don't know if that information is very, very well documented in the format. I think it's not, right? Oh no, you have two simultaneous events. That's right. Which sometimes there's not. It just kind of doesn't work sometimes, if I recall correctly. Luau moment. But yeah, this is, I actually ran this to completion, the serializer here. Here it is. So serialize. So the input is a list of timelines, and it's like the complete timelines of the whole file, and a writer. So what are you writing the output file to? And it just has a whole algorithm that plans out the data blocks and then writes them. So plan timeline. This has a function that asks what the next event is, and this is that function. So it just repeatedly calls this function to query what the next event should be. So it's just like comparing the events from each timeline to see if that one is the soonest, so that it can take the soonest one and put it into the block, or into the plan rather. It's planning before it writes. It does no actual serialization until the plan is complete, which is different than the Roblox encoder. I think it does serialize while it's planning. So yeah, this is just like comparing which one should be the soonest, and it found whichever one should be the soonest, and then it includes it in the plan. And that looks like this: accumulate. Just, it takes the index and adds one to it. There's 8 different indices, one for each timeline, and so it just like adds one to the index for each timeline to include it in the plan. And then once the block is full, it creates a range from the last checkpoint. So like, it starts at all plan indices are 0. There's 8 indices. All indices are 0 for all the timelines, and it adds like some to that. And then now the plan is over here, and now you have a range of indices that should be included in that block. And then it like updates the checkpoint, and then plans some more. Those make a new range. That's how it works. So it plans these 2 timelines with this big machine that has rather deep nesting. Size increase, accumulate. It's calling all these functions. And then now they're all fully planned. But they're in order, and it has to go not in order. It has to create this block timelines, whereas this thing. So each block needs to like exist somewhere in the file, right? So the block positions defines the starting point of the block, and it's just sort of like the location of the separation points between the blocks, where each block starts. And it also includes one extra element at the very end of the file to say like, yes, this is the end of the file. So you can take block position I and block position I+1 and say that's a range, that's a specific block. And then these are different. This is in chronological order. So this is in data order that the data is written to the file. And these are in chronological order, and they point to the ID in this list. So like, oh, block number 4, that's the fourth item in this list. That's the fourth block in the file. But block number 4 appears first in the file, or whatever it is. It's actually, block number 1 is always the first one in this list. And block number 2 is always the first one in this list. And block number 3 is always the last one in this list. And then from there on, the blocks appear within the file in chronological order, interlaced between the two lists. And that's what this thing is doing. So we have the overall position, where we are generating this list in the order that they appear in the file. And push block is like is creating the plan in the order that they appear in the file. So that this is like what range of events should this block contain? And this is indexed by block ID. So the first element of the list is block 1, and block 2, block 3. Yeah. So you can see that it writes down the position before the block is pushed, and then it increments the position by the size of the block. So this function is a little bit complicated. Where is it? There it is. So we're filtering out empty. If there's a timeline in the block that doesn't have any events, then it doesn't need a chunk header. Otherwise, it adds how many events there are times the size of each event, and that comes from here. And then plus the chunk header. It has to also include the chunk header. Very cool. So then, because we're writing them out of order, we need to remember what the index was, which is written right here. So this is kind of like randomly writing to the timeline here, and this is the timeline because it's going in file order, whereas the timeline is in chronological order. But it all works out. It eventually will fill all of the elements. You can see I'm like pre-allocating this list with dummy blocks that are all just 0. Eventually it fills them all with real data. So this is the real data. Yeah, and so you can see block ID plus equals 1. We're going in file order. So the first block to be pushed is the first block in the offline timeline, which is very poorly named. It's like sounds. No, it's not sounds. Sounds are in the real time, aren't they? I don't actually remember. I have it written down here. Yeah. So sounds are real time. Uh, Offline is things that need to be accumulated. So if you change your FOV setting, you can't just skip over that. You have to like know that the FOV was changed, change the FOV, and from there on, the state is changed forever. Whereas if you jump over a sound playback, you jumped ahead of it in the file. Like you don't want to hear all the sounds before, like if you're like scanning on the like YouTube video seek bar, you don't want to hear the entire YouTube video between when you jumped ahead. So that's the difference between the offline timeline and the real-time timeline. Very poorly named. So the we have to like sort of initialize the state. So that's why it's the first block. Is it's all of the state setup. Like it includes your FOV and your other settings, and also the gravity and stuff. So that's sort of like setting up the state. Often there's only one offline block. Not every map has this sort of like gravity changes and other things that affect this. Usually there's only one in the entire file, but there can be more than one. So yeah. And then the first real time, so this is from the front of the list, gets pushed in. So this is the first block, the second block, the third block. So this is the last real-time event at the very end of the file when you hit the finish zone. And this is included at the beginning of the file so that the streaming can work, where you just need the first 3 blocks of the file, and then you know all of the initialization information to start playback. You have the beginning of the playback, the very start of the recording, and you also know how long the recording is because you have the end of the recording. And so I don't need any special information like how long is the recording, because you can just like look at the timestamps and be like, oh, this is how long the recording is. I was very pleased when I didn't need to have like a special metadata type piece of information, and everything can just be sort of implied by the data within the file. Okay, then once the 3 blocks are pushed in, it sorts them by time. So it's joining 2 iterators, and that's the remaining offline blocks and the remaining real-time blocks. So we popped these ones off. They're no longer in the timelines. And then the rest of them are like sorted by time, whichever time is smallest, and then pushed in. So whatever time comes first. So that's all the remaining blocks, and then it writes down the final position, and then now the plan is complete, and it can create the timelines header, and this is the actual file writing at the very end. Writes the file header, writes the timelines header, writes all the blocks according to the plan, all according to Keikaku. I hope I said that right. Amazing. I think this is similar to the Roblox one, but it might be a better algorithm. I don't remember. Do I have any sorting? Because I didn't actually need any sorting other than this, which is pretty cool. Very cool. I'm thinking about read all to block. I think I can actually remove iter tools from this and read these separately. I don't need to actually merge the iterators because the offline blocks only contain offline events, and the real-time blocks only contain real-time events, so they won't clobber each other. So this is like kind of safer, where like if there was a invalid file, then this would contain all the data. Well, I guess it doesn't really protect against really bad files. So like, yeah, maybe I should just extend from reader. Huh. Huh. So I could totally do them separate. Then I wouldn't need the iter tools for this function. Uh-huh. The only thing is that I have to pull this part out of this function, and it's a bit janky. I could have it be like a member function of this. Extend from iter. Now I'm interested. All right, I'm gonna like throw away my day today and do this. Actually no. That just made it sound bad when I said it out loud. I'm gonna not do that. Okay. I'm gonna write it down and then do that after 2 hours. Okay. I've been yapping for 46 minutes. Oh my god. Yep, yappity yapper. Okay. Let's see. Where am I? I can just say to do remove iter tools. The blocks don't interfere. So just decode them the timelines chronologically separately. Okay, that's written down. Okay, we must think, and by we, I mean me. I must think. I must think. We must stay focused. Oh, okay. Debug. Okay. We must stay focused. What we doing? I have a bug. So I'm writing a physics system. I like to say physics system and not physics engine because it's a physics system for one body, one object. It's not like multiple things. You don't have like a basket of apples or something. I guess I can just demonstrate. Strafe. I will build this version. And then run it. Yes. Build. Is this connected to the bhub game? You will see in a second. Yes, it is connected to the bhub game. So there is this bug where the physics doesn't work, and that's what I'm trying to fix. Oh my god. It works amazingly well for all right, so this one actually doesn't work. So I don't know why, but oh wait. What? Oh, this is the wrong version. Oh, did it print the thing? It did not print the thing. Oh, okay. In what way did the physics not physic? Well, so this is a repro. Yes. So, goodness gracious, goodness gravy me. Failing test loop. Goodness. There's so much crap here. Okay, it's actually rather in depth and complicated. It goes deep. So, 2 years ago, I wrote this code, and I didn't have a way to set up the algorithm. Okay, I'm gonna explain. So what the algorithm does is, if you have a starting point, it can like run time forward and check to see if it intersects. It has that capability. But I didn't have a way to set it up at that starting point. To set up the initial state of the algorithm. And so what I did was, instead of running time forwards, I ran time backwards to infinity as a janky way to set up the algorithm. And then from infinity, it's easier to set up the algorithm. So I just went like, here it comes. Ah, that's the initial state. And that's a waste of time. That I'm just like throwing processing power away. But so I sort of like planned to make it better later. So that's kind of the background. So now I have discovered that the algorithm to set up the physics actually already exists in my Roblox bhub game in Lua. And so the last 2 weeks, I've been porting the Lua code into Rust because it actually does exactly what I need. And then last week, on Friday, I think, I discovered that I had been like debugging the ported algorithm because I wasn't sure if it was correct or not. And it like wasn't always working. And I found out that it was correct, but it was feeding information into the algorithm that can like run time forwards and tell you if it collides was actually wrong. The code I already wrote was wrong. And the setup algorithm was more correct than the one that came in from infinity. And so the physics algorithm had never started off correctly before. And now that it was starting off correctly, it was running in a slightly different way that it was never running before. And so I never noticed that it was wrong because it was never fed correct information. So that's where I am right now. It's like, what is wrong? What is right? How do I find out? What? So the code that I trusted has let me down, and I need to find out why, where, how, what's happening. Okay, let's run this code. So this is the min-diff algorithm. It's very complicated, but it's exactly what I need. You have a mesh, you have a point. It tells you, is the point inside the mesh? And it even does better than that. It tells you where on the mesh is closest to that test point. So like, if I have this mesh, and then I'm like, okay, where's the closest point on the mesh to this point? It's right there. And it'll tell me actually it's the yellow face that contains that closest point. And that's exactly the information that I need for the physics algorithm. How fast can you solve a 3x3? I don't know, like 10 minutes. I'm not a speed cuber by any means. I don't even remember the algorithms to like flip these properly. I got like partial things of it as like a half experienced developer. This is very niche and very like deep, in depth. It's like diving straight to the bottom of the physics pool, writing physics engines. So over the years, I've developed ways to like use these props and like explain what's actually going on. But it is for sure really complicated. I don't even get it sometimes, which is why I explain it a lot. It kind of like refreshes how it works in my mind. Wow, it's the minimum bit right. I was gonna compile it and run it and just like look at it, see what happens. All right, we're compiling the version with the new algorithm running, which is what I thought I was doing last time. Cool. All right, so it seems to work really well, which was a huge shock. Excuse me. When I got the algorithm working to this extent, I was blown away. This is like new code. Wow, it's working. It's a totally new algorithm. It's much faster than the one that like comes in from infinity, because it doesn't have to like travel through all space and time infinitely to reach the starting point. It just directly calculates the starting point. So it's much more efficient, which I'm excited about. And I like planned to do that from the beginning, but I didn't really. Oops. I didn't have a way to do it yet, and now I do. Hooray! So this object. The squares seem to work great. Wow, I can jump on the squares. But this object, do you remember before I was like jumping on this and I could actually hit it and jump off? Well, now I can't. And so the new algorithm doesn't work for this thing. And I do not know why. It also So it basically only works for this like special case where you have an axis aligned box that's not rotated randomly. It's like X points in X, Y points in Y, Z points in Z. Two axis aligned boxes like this. It only works like this. If you rotate it a bit, it doesn't work. If you rotate it a bit, it doesn't work. So it's very strange. Fortunately, most cases in bhop maps are that like axis aligned boxes, but right here, this is not axis aligned boxes. It does not work. It does not work. You just kind of like go through it a lot of the time, which doesn't happen in the other version. So in the general case, this new algorithm seems to be failing. And last week, I discovered that it always happens when the starting point. So the starting point for the algorithm. This is the face crawler. The face crawler is the algorithm that can run time forward and find the time of collision. This is the main physics algorithm. What it's actually doing is it's like crawling across the face of the object, the surface of the mesh. So if you have the starting point, you know which face you're starting on, and then you can trace, the closest point is like moving through space. You can trace where on the mesh is closest to the closest point, and that is the crawling in the face crawler. It's like tracing on the surface of the mesh the current closest point as your like test point moves through space. Doesn't solo developing get boring? God, there's so much depth. Get bored when coding alone. Would I have a friend to test stuff? Feel like I can do more stuff. No, I would have to say no. There's so much work to do. And I always have so many ideas to explore. Still got to figure out what's causing the run to not start until you hit a trigger. It's probably the same bug. It's probably just it's not setting up. What does it look like? Let's take a look at that. It's predict collision out. No, is it face out? No, it's just out. So face out is like you're standing on something, and so you're standing on something. You're gonna stop touching one of the faces, so it only has to pay attention to one face of the mesh. Whereas this one, you're like intersecting. You're inside the mesh, so it needs to like figure out. Oh. 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 Yeah, no, this is big wrong. Huh. Okay. Well, that's very, very wrong. So this is very much inside the mesh, intersecting. So you're inside the start zone when you start the game. So closest fev not inside will give you nothing because you are inside. And so this just goes like, and just exits immediately, the algorithm. Let's look at the Use new algorithm. This is where I implemented it. Right here, right here. Predict collision in. Aha, look. I took this and moved it to the top. Totally wrong. It has to be like this. I have to use this infinity body thing. Totally wrong. Oops. So I have to mimic this call right here. Infinity body and a lower bound. Oh, there's okay. So this has to go here. Infinity body. Help. Infinity body. I don't think lower bound. This is not extrapolated. The negative body is time inverted. So it does negative velocity, negative time. Negative velocity, negative time. This is time inversion. I should probably make this a dedicated function like dot invert time or something instead of negation. Yeah. And then, so that doesn't change the position. So it's still going to not work. Why did the other one work? So the other one says dot miss, right? No. How the hell does this work? Closest have not inside is start time? Miss. 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 So this is extrapolating the body backwards in time to the beginning of the path volume for this like game tick, this update. But in a way that's exact instead of like recalculating the body. That is very wrong. Very, very wrong. So interestingly, this algorithm can actually tell you which surface is closest when you're intersecting. Trey's algorithm is amazing. But I didn't port that part of the algorithm, and I actually think that I don't need to port that part of the algorithm. Because it's not necessary. And it's also incorrect. In this, it can lead to an incorrect result. I'm trying to figure out how I can like explain this without drawing it. I think I'm just going to draw it. Okay, so our algorithm is trying to determine when a point leaves a mesh. New. Okay. Geez. So how do you do that? So we have a box and we have a point. Wow, it's inside. Wow. And then we have another test point. Wow, it's outside. Wow. But our cases are all path volumes, which for a point is just like a line. So the point moved from here to here. And in this function, predict collision out, we're trying to determine if the line exited the mesh. So it won't care if it enters it. It's only, do you predict that there's a exit point? And so we already have the predict collision in. And that's easy. He said currently. So this one says, what's the closest fab that's not inside the mesh? Based on the starting position. So boom. Oh, it's this one. This face, that's the closest. Cool. And then it does a crawl along the surface to see when it hits. So that's just like crawl, 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 hit. So like if your starting point is here and your path goes like this, then it goes crawl, 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 hit. Cool. What if your point starts inside and goes outside? Well, wait, can we actually just crawl? No. No. There is discontinuities on the inside. So like when you're going around the outside, it always goes from a face onto a vertex onto a face. And it always sort of like cleanly transitions. But if you're going on the inside, it's like, all right, this is the closest point. This is the closest point. This is the closest point. Jump! Now this is the closest point. Now this is the closest point. So there's a discontinuity within the object, and you can't like really know where that is or what that's doing without doing a bunch of calculations ahead of time that are expensive. So there's an easy way to solve this. So we're trying to determine if it goes out of the mesh. Why don't we just invert time? So we start here, we end here, and it's going this way. What if we just start here and end here and go this way? And then, so that's just, we just run the collision in algorithm backwards in time. That would work, right? That would just exactly work. So it goes like, there's the hit. So you hit it after this many seconds. You exit after this many seconds if it just comes from the outside. And yeah, that just works. So the old one was just sort of cutting the crawl short. The crawl in from infinity. So it's like, why don't I erase everything else? So it was doing the same thing. You had the starting point and the ending point, and just like crawl in from infinity to get the like starting condition, and then it would trace across the surface to find the hit point. And so it was useful to be able to pass the time in. Pass the time. So I'm passing in No, that's the collision in. I was passing in this time bounds, and then I was negating and swapping the bounds. So the lower bound becomes the upper bound, and the upper bound becomes the lower bound, and they're negative time as well. And then I was now passing in the new lower bound. So the crawl would stop at that time instead of going all the way to the starting point. And that was like nice and exact. But now I have to pass a position, a starting position. I think it'll work out. I think I can just extrapolate to the end. Oh my god. And it's so the edge cases are when the position is exactly on the surface of the mesh. Okay, what is this called? Extrapolate. Position. Is it a ratio dt? No, it's a time. Extrapolated position, time. It might just be fine, though. Oof. So it's actually possible for there to be no time bound. Which actually necessarily requires the infinity fev algorithm. If not, I'm thinking of it. Because this time bound can possibly not exist. Bound. So bound, there's three types of bounds. There's included, so the endpoint is included in the bounds. There's excluded, where the endpoint is not part of the bound, and then there's unbounded, where there is no endpoint. And that's like in math, where you have like a inclusive range from 0 to 1, or you have an exclusive range where it doesn't include 1. That's the exact same thing. And then there's unbounded, where like 0 is the lowest, but it can go up to infinity. So both the lower and upper bounds can either be unbounded or bounded. And so extrapolating based on a time value, well, if there's no time value, you can't extrapolate. mm, mm. So this always works forwards in time because you always start outside. So you always have a starting point. So it's always easy to set up using this minimum difference algorithm. But with the other one, maybe you don't have an ending time for the collision out. Maybe it's unbounded. So running that backwards means you're running backwards from infinity. In practice, there will always be a bound. Um, but damn. Lower bound. Haba. Let's see. Lower bound. Is it the lower bound or is it the upper bound? I forgot. It's the lower bound. The lower bound comes from the upper bound, and the upper bound is the end of the range. Lower bound dot time. It's I guess I need to match it. Can I do like 2 option hash? What? Bound as ref. Yeah, no, I guess it's kind of goobed. FF. Okay, it is map, but also I don't care. How do I make this not suck? I don't think I have a way to make it not suck. So let's just do it. So this is both of these have a time. This one has no time. And then this just takes the time. Infinity body extrapolated position, question mark. So actually, instead of return none, this is a panic. Unbound, unimplemented. Unbounded collision. Damn. I think that actually fixes the bug. So let's test it. So this algorithm is what was determining the start zone, and it was wrong. It was just wrong. I did it wrong. So it should be kind of right now. Maybe with edge cases, I'm not sure. Okay, what the heck is going on with my CPU? Who is using all the CPU? OBS. That usually isn't a problem. Okay. I did it. Okay. We run the track. So we should, it should just work. It didn't just work. Starting new run. It didn't just work. So what happens is why it starts when you hit a trigger is because you teleported and it has to recalculate all the collisions, and so it recalculates all the collisions using the minimum difference algorithm, and yeah, and it works correctly, whereas the predict collision out is apparently not working at all. Hmm. Can I like make it work ever? No. 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 What did I get wrong? Ugh. All right, this is confusing. I'm just gonna like move it up and do it like this. We'll go off the upper bound and use the relative body here. Consider dereferencing. Consider the following. So I should work. Maybe I just got the logic backwards or something. It should work. It should work. Please work. Yeah, both of these should be equivalent. But this is an exit point, so doing it earlier is probably better. Trait start bound. Sheesh. Yeah, I guess this code is better. So okay, my guess now that it's just hitting the edge case. But it shouldn't be. It should be literally just running backwards and chilling. Like if the normal physics works, this should also work. Yeah, I don't know why it's not working. Is it working for a different reason than I think? I have no idea. I have no idea. This is like very, very complicated. There's so many moving pieces that can go wrong. I don't have enough tests to know which pieces are going wrong. I don't have a lot of like inner tests for the face crawler. I'm only testing like the final result of like, is the collision correct, rather than like, is this transition across the surface correct? But I'm glad I saw this. Thank you, Aiden, for bringing that up. And you hit a trigger and force recalculation. Oh, yeah, so you already know that it was doing that. I don't see how this could be wrong. It should be. Oh, is it this? Wait. Hold on. Does this work? It does. So why does it not work when the time is inverted? Wait. I can't get away from the wall. What? What was that? Oh. Oh, it might have been this. What the hell was that? Arrgh. So complicated. Why doesn't it work? Why does it work? Why does it work and why doesn't it work? It's like both of them are running at the same time, where it's like both working and not working. Uh, so it always goes through this case. Is it this one that's wrong? I feel like it's not this one that's wrong. Maybe it's this one that's wrong. And probably it's not this that's wrong. Probably it's the Minkowski sum implementation of like edge faces or something. Because like this one is only using face edges and edge verts, which are something else. Whereas this one, okay, let's go to the proc and print edge face, because it always has to go out. Yeah, let's do print edge face. Huh. Oh, yeah. Wait. Oh. Okay. Okay. Yeah, we go. Okay, so I know it's touching vert, but is touching edge also that rare? We do not know. So yeah, so it looks like we're not touching any edges so far. So 99.999% of the physics tests are all not the tests, but the collision tests that are running the like actual running physics are the face cases. Oh look, there is edge. Okay, so it's not like having bugs. Until we get to here. Wait, why is it working? Oh, it's the... okay. Right. So, yeah, so this is like the rare cases, but at the same time, it's like freaking, it's working. So let's figure this out. Hmm. Oh, that happened. I didn't see it. Edge. Was it this one? Let's see if I can do it again. Wait. Wait, what? It didn't print that time. Oh, yeah. Did I get RNG'd on? And this is not the root cause? When I fell through that log, it did not print a fev vert to edge transition, like this one. This is a vert to edge transition. Fev vert transitioning to edge. But it did print edge, maybe. Do I have mesh query on this thing? Is this thing mesh query? Ish. Model mesh query output is what? So it wouldn't fit these trait bounds. Because it's hard coded for Minkowski mesh, even though it's a mesh query generic. I could mega hard code it and then copy paste it for the physics mesh and then try to run every case I can think of. Oh man. Would we be in 402 if no. Cuz like this is not 4. Right? So ND, yeah, no, it's just literally not. It would be like a 2. This one is graciously a 2. F. F mul output 4. Go ahead. And this is not a trait. Yeah, this would all go away with const generics. He's begging for const generics. What is my computer doing, man? Keeps revving up and down. Don't. This is why I switched from Windows. One of the reasons. Is it like Discord updater or something? I have no idea. Yeah, I think this is somewhat a matter of cart before the horse, where I'm like using the algorithms without testing them and then testing the final outcome and praying that it works. Is there another way? Think just a little bit longer. So I thought for sure I would be diving into the face crawler algorithm and like bug hunting there, but I didn't see it proc on the proc branch that's supposed to proc it. So it didn't actually transition through so it can happen. There's 2 bugs. I don't know. I don't know. I don't know. I don't know. From what I saw, the algorithm was giving the face crawler a correct vertex. And then the face crawler just didn't work correctly on its own. From what I saw. Okay, so I'm thinking about a visual debug of the minimum difference. Um, I could run it. Oh, I can even Minkowski. Excuse me. I could even like. Damn, that's crazy. Delegation. What was I just saying? So remember the mouse ray tracer that like highlights which part you're looking at. What if I did that and I also ran the closest fev algorithm and highlighted the closest fev so you can aim at any part and see what the closest fev is or what it thinks the closest fev is. Yeah. That would be kind of involved. I would have to add a new like drawing pipeline to draw lines and points. I don't know. But like I could verify that it's giving correct results and that it's not the problem. I have one known case where I know that it's giving a correct result and the face crawler is failing on its own. And it's a vert. So it's a vert to edge transition. It gives out a vert. The face crawler just kind of doesn't work. And I also know nice spelling. I also know that the knee algorithm northeast model physics zoop this one right here parabola edge north from northeast 100. It's kind of crazy that every single one of these fails. Isn't this one wrong? If okay, let's look at them. So I know that the knee gives a right answer, wrong crawl. What about this one? Let's do south from north. Huh. What? Is that? Are we doing vert here? Blah, 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 blah. Let's see. Let's see. So Min diff face crawler. Yeah, I want this crap. Right? This is on here. Yeah, give me that crap. Test fail, reduce 3. Give me that crap. That crap. Pop. Crap. Okay. Nor. Okay. Okay, so I want to run the test north from south. Let me look at it. Look at it. South from north. Well, let's do like north from south. I think that one would be more obvious. From south. Z. That's Z. North from south. So you're traveling in the negative Z direction, which is towards the north from the south, and the contact point is -3 Z, which is northernly. So you expect to collide at -3 coming from the south. So this makes sense. North from south. Boom. No capture. We maybe see this give edge face edge. So it is that correct? I don't know. Okay, let's think about this. So you are extrapolating backwards in time by 1 second. So the acceleration is down and your velocity is down. So, okay, so you're going like, and you're going to smack like right there. You're going, so this is -3 Z. So you're going like real fast. So you're gonna be up by 0.5 units and back by 100 units. Yeah, that's correct. So it's returning that this edge and this edge are the closest distance between them, which is true. That's the closest point. It's actually finding the freaking edge. The whole edge, even in the edge case. So like, yeah. Wow. Crazy good algorithm. Whoever made this algorithm, genius. It was Trey. So face to edge. What doing? Edge to face. And then face to edge. Why would he do like that? We look. Who did this? So we go here. Proc. No. Yes. So I can go here, and I can have the same printing a little bit, kind of. Just a little bit printing. I'm gonna like cherry, fail, cherry, fail. Okay, a little bit printing, a little bit. So if we run this test again, I think we'll see something else. It'll print something else. No, it prints the same. Edge, face, edge. Face, edge. Really? So let me just add a little debug handle here. Huh? Make sure it's not in the wrong one. Oh. Oh, the test is okay. Whoa. It should definitely be printing. Why is it not printing? Uh, collision in fev, not inside fev. So let's see. Print line. Predict collision in fev equals fev. Probably question mark. Yeah. Okay. So what are you telling me? Face. Face edge edge. Oh my goodness. Wait, but why is it calling this twice? Oh, right. It does two, doesn't it? On the physics test. Test collision. Axis aligned rotated. Okay. Wait. Which one's failing? Does the axis aligned one pass? Wait a minute. Who did this? Test. How do you trace back? Just run it. I can just print. I'm just gonna print. Print. Why would I bother not printing? All right, go. Test collision, axis aligned. Oh, I thought it succeeded for a second. Okay, so dang. Okay, so the axis aligned collision is not working. Dang. Yeah. So this is like really correct. It's returning an edge from the minimum difference algorithm, which I think is correct. How the hell did the infinity fev algorithm ever work? Oh man. Let me grab this thing and like print it. Where did it go? Who did this? Physics? No. Collision in, please. Infinity collision in right here. Print it. Print it. So yeah, I think this shows an edge. So this one shows face, even though an edge is actually the closest. But I don't know. I don't know. Why does it work? Yeah, edge. Wait, edge vert. Whoa. That's an acceptable answer, if I am understanding correctly. It might be just like the wrong edge. So like, edge vert. Is this deterministic? So if they're like this, right, and they're just chilling like that, then this edge and this edge, you could be like, oh yeah, that's the closest edge between the two meshes. That makes sense. Oh. Oh. Okay. Okay, so, okay. Okay, the infinity fab algorithm is crawling in from infinity. It's like, but that always means it will continue in the same direction on the same path. And so even if it returns like, oh, we're on this face and this face, these are like this face and this face are the closest. It's wrong, but it doesn't matter because it'll immediately just go like, oh, and then there. Or is that true? Isn't that in the past though? How does this algorithm work? Why does it work? It doesn't make sense. How did anything work ever? Until now. And now it's broken. No, that's poor phrasing. How did anything work with the old code? And now the new code is actually giving it a correct answer and it's not working. Okay, so okay, I'm glad I looked at this test case. So last time we looked at the test case where it's like coming in from the side here, and that was actually vert in terms of the closest point. Let's run it with a straight line and see if it makes a difference. I think it won't, but where's the test? Test parabola, edge north from south. And then we set the acceleration to 0, so it just comes in on a straight line. Does it work? No. Okay. So it says no time of collision. Okay. Edge vert. It's deterministic. Okay. So it just looks like it could be correct. I don't know the exact vertex. Okay, I'm going to try printing the vertex output of the minimum difference algorithm to validate it by Gabagoo. To validate it by the position of the vertices rather than the topology, because that's really what the important part is. So it's Minkowski. It's Minkowski. I don't have permission to separate them though. It's debugging time. Okay, public. Go for it. Go for it, man. Go ham. Oh god. Minimum difference. So I want to print the vertex positions of mesh 0 and the vertex positions of mesh 1. So mesh 0 v0 equals mesh 0 dot vert v0. Oh god, Minkowski vert. I have to decouple the Minkowski vert. I should really remove this. It's a huge pain. Whatever. No, nobody cares. Nobody cares. Just do it. Do it. Match. This is what I mean by it's a pain. Okay. Print that sucker to death. Yay! Okay. So we have mesh 0 and we have mesh 1. So it's starting here on the north face and moving backwards like this. So we should expect to see the vertices on mesh 0 be on the top front face, and on mesh 1 be on the... Is this the back face? I don't know. It's a positive Z face. And then this be on the negative Z face on the negative Y. So mesh 0 doesn't matter. Top positive Z doesn't matter. Top positive Z. Mesh 1 doesn't matter. Bottom negative Z doesn't matter. Bottom negative Z. Exactly correct. Exactly what I expected. Yeah, it looks like it is working, at least in the cases I've looked at. I think the min-diff algorithm is correct, and the face crawler is breaking for no reason. It was wrong, and it just never happened for some reason. Oh, it's a square. So yeah. What do I do about this information? Uh, from the looks of it, the port is complete. The minimum difference algorithm is returning correct results. Hooray! All the evidence, I've actually only have two pieces of evidence here. All the evidence I've seen indicates that it is correct. But it would seem that the face crawler can't handle the truth. And it breaks whenever it gives a correct answer that the old algorithm didn't give. So somewhere from giving the result to the next transition, one of the next transitions, it's wrong. So it's, does that mean it's in the face crawler? Not necessarily. It could be in the Minkowski queries. I don't know what to do. Unit tests. I just don't have an easy to visualize method. Like, what would be fantastic if I could put on VR goggles, hold two meshes, and go like this and see the algorithm working and like making it work. And then like go like this and let go and watch it go crawl across the surface. God, that would be amazing. Yeah, highlight the meshes. I'm basically missing visualization tools that I can watch. I was talking about this last year, or maybe this year even, and I was going to try hard to make them, but like it was such a big task that I never even started. This is beautiful code here. Yeah, it's brilliant. Like this function, the fact that it includes the it's like reusing all the same code. We got the finder crawl boundaries. It's beautiful. I sh ma I sh I should be able to use this code for the Infinity Fev still. incredible. It's so incredible that the new untrusted code is wrong, and the old or no the opposite. The new untrusted code is correct, and the old trusted code is rearing its ugly warts. It's simply not correct, I think. Is there just some kind of like parity flipping going on where like I've incorrectly triple flipped the parity or something ridiculous? Whoa. Yeah, this algorithm is actually should be more correct than it previously was, and it's more general with the EV finder. Thick line, thick plane. It's pretty neat. Trey's code is flawless. Every time I use Trey's code, it just makes everything better. He just thinks so hard about everything. Like the way it's set up. Look at this. I got platform mesh, hitbox mesh, mesh 0, mesh 1. Relative body should add to mesh 1. But like the swap shouldn't. It only matters for like asymmetry. Oh, I can't believe I wrote the whole thing backwards. What an idiot. What happens if I double invert it? Oops. So mesh 0, this is negative, positive, we expect. Yeah. So it's totally backwards. So we expect it to be up back, but it's down front. I don't know what to do once again. The most useful thing to have would be a visualization. Of the face crawler running. What if I like made it in Love 2D and I like made like Lua bindings to the Rust code or something? This sounds like more work. Just so much like rebasing and stuff. Let me open the mouse version. I don't even know what it's called or where it is. Debug. Graphics. Real? What is debug graphics? Who did this? This line goes down here. Entity debug. Yeah. Debug models visually. Hell yeah. Debug graphics. Oh god. Print body position. Good gravy. Okay, if I go here, when we build that sucker, what happens? Should work. Hooray. So look at that. Now it highlights whatever I'm looking at. So my idea would be to highlight the closest point. So we go like, it would like highlight the edge or the vertex if those are the closest point, or the face if that's the closest point. But I guess that's kind of, the face might be kind of iffy, cause like, well, no, I could. Oh, uh-oh. It wrong? It wrong? Why it wrong? Oh. I have to make an entirely new graphics pipeline to do that. Sometimes it's just wrong. I love the little edges. The BVH traversal. I like worked hard on this. You can't really see that. I'd have to go over there. Now you can see it. Does it work if I like face the other way and stuff? Yeah. Pretty good. So yeah, that's like a nice debug of all of the edges and stuff. Of all the different meshes going on. Doesn't really affect the performance that much, which is kind of crazy. Yeah, it's crawling through a bunch of BVHs and it's still fast. Brilliant, brilliant, brilliant. Brilliant, brilliant, brilliant. It is only running once. Does this ever break? It was breaking in that other one. I don't know why. Okay. That's cool, that's cool, that's cool. That was tough to write. So let's see. Where is the comments? Oh, there's not that many. There's not that many. Physics data trace ray. Okay, and then yeah. Debug physics models visually. Fix compile. You see this whole thing? Like this kind of is 200 lines of code. Adding this is graphics. So let's see. It's like making a complete separate copy of the map, just so you can draw the original model, because it does all sort of transformations to the graphics to like draw things simultaneously as one model. But like I want to see the original model, so I need to clone the entire map. So there's two copies of the map in this version. Create bind group layout. Vertex fragment. No way. Create pipeline. Wow. So I have to create an entirely new render pipeline to do this. Would I make like 3 more? Would that be it? Would that be it? Alpha blending, clockwise front, depth stencil. We're drawing lines. Fragment shader. Primitive. Face. We ain't. How do you say I'm drawing lines? Attributes, buffers, vertex buffer layout. Aha. Aha. I could also like just like query a bunch of parts nearby and draw all of the closest points for those. That would be interesting. Yeah, I think that with the mouse is better because like I can. BVH iter 2. BVH iter 2. Debug raycast print model ID if change. XDXD. Ray equals last ray hit equals model ID. Yeah. Whatever, just do it. Exactly. Exactly. Well, this is the origin, and this is fixed compile. I think we can push that easy clap. And then let's try rebase. Rebase onto mindiff. Yeah. Generate models. New. Yeah, okay. So what do we want both here, but we only care about this, so grab it and dab it. All conflicts resolved. Smells like dinner. Continue. Resolve. Really? I appear to have changed this. Get instance buffer data. Did I really do that? Get instance buffer data. Boy. Yo. Get instance buffer data. So that'll be up on the camera here somewhere. Should be pretty obvious. There it is. So it doesn't exist there. Get instance buffer data. I just moved it. Real. What does the old one look like? Is that literally exactly the same code? No. Get instance buffer data. F32 model buffer size. Oh. Transform x-axis as ref. Changed it. Init vec with capacity out. Why is the new one vec with capacity? What did I do to deserve that? This one looks better, honestly. Oh, it's a slice. Oh. I see. I see. So this is a loop over the instances, and then this is like goobing right here. Okay. Yeah, so it just doesn't need to do that. Okay. Can't this just be like push? I think this goes away. And it's chilling. This looks like push. Like, what am I doing? Sure. Continue. Resolve. Yarg. There is no conflicts. What? 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 Okay, I'll do it with this one. So this guy we got iter internal. And then this guy we got impl physics trace array generate models. So where's the it looks like it's moved. Oh god. Grab both of them and then I'm gonna locate the other guy here. Physics context. So like, wait, what? Physics context. Iter internal, and then it ends with physics objects. So it ends with these. That's so idiotic. Okay. Okay, and then we're looking for physics model. This is the trouble with like shuffling code around, is these old patches. Can't find it. Physics. Was it physics models? Was it? Or was it physics data? It's physics data. Oh, jeez. Empty trace array new. So it should be like to here. Situation. Yeah, this is like new. Let's see. What's the diff here? So there will be some new and some old code here. So yeah, we're gonna want the old version of this. Oh, we have 2 trace arrays. Haha, fix XD. Jeez. Oh, yeah, no, that's right. That's right. Let's do this. Okay, so what is it doing? Use entry or insert with. So I did actually do that. Use with caution. As ref. I think this was the only change, right? It actually was just only asref, and then the rest of this is just crap. Oh. Did I make a mistake? Okay, what happens when we try to compile it? Probably doesn't compile. That's not bad. Okay, physics 1006. Faces. How did that change? Trace ray. Okay. Is this based on something else? Mesh. What is this called? Debug graphics with a D. Okay, let's look at the branch. Okay, it goes to here. We got BVH iter. It goes to here. Physics set style and reset. Trace ray. This just says faces. Did I used to have that? And now I don't. Hello? Whoa. So, whip, faces. Whip. I fixed the algorithm. What? Faces. Whole word match case. Jeez. None. Okay, faces. Where's that stupid function? There is no function. So, let's find verts then. Verts. Don't I have a verts? Brute force every face. Yeah. What happened to this function? Did I remove it? Flush face transfer. Ah! I did. Fix dead code lints. That's GG. Okay. So I did actually remove it. Let's see if it's just cherry picks. Damn. Verts. Verts, yeah, there it is. Give me that. Yeah. Okay, so now graphics don't be doing very hot. Get instance buffer data. Get instances buffer data. Did I introduce anything in session here? Musta. Yeah, let's go, lints. Setup. Huge. Okay. There we go. Okay, so it's fix rebase. Fix rebase. Bow. Bow. And then fix lints. Bow. I'll rename this to debug graphics 2. Who did this? Where is this? Where's this branch? There it is. Rename branch. Debug graphics 2. Build it. Can we see again? Let's go. Arcane? No panics. Woo! We can see it again. This is on the latest version. Okay, is it like broken like before? Or are there like subtle bugs all fixed up? It's not showing it. I don't know why it doesn't show that. Why can't it see this one? What the heck? It's like just this one specifically, it just can't see. And then all the other ones just like, oh yeah. What the heck? What? So that's probably a bounding volume extent where like it just reaches to like around this and not around those ones. And like my BVH crawl algorithm is wrong somehow, and I don't know. This is neat. I actually was able to rebase. That's it's very nice knowing your code base. So that is on MinDiff, right? So this is like broken? Yeah, this is on MinDiff. So that wasn't too painful. So now what I want to do is add 3 more pipelines. No, add 2 more pipelines for a total of 3 new ones. This one, the red stuff is a new pipeline. So cool. Nah. Yeah. Sometimes it works, sometimes it doesn't work. God, that's so cool. Just having made everything manually, and it runs to 2000 FPS. Hard work. Okay. Okay, well done. Ooh. Trace ray. Graphics. Yeah. Compile. Is that this function? Yeah. So I can actually goob this, right? Fix up. That way I don't have to do it again. Yeah. Sample ray. The function was, it's not used. Is it? Didn't I? Bro, open the code. How come? Oh, it's pub. Oh, I see. So it's not used, but it's, okay. Yeah. Okay. Damn. ND is 0. Then T. Why don't I do then some? Oh, it's a. What is this? Bool? Isn't it then some? Am I stupid? Yeah. What? Face edges iter all. Face edges iter all. Yeah. T true. That makes sense. Just brute force. Yeah, no, it makes sense. Oh, yeah. Haha. I could totally use the face crawler. That'd be funny. Haha. Oh, min. Ha, lol. Wait, why don't I do min by? What am I doing? Can't I do min by? Min by key? Into min. Wait, I just need the T. Right. Filter map. Oh. T. Right. Yeah, no. Because, like, if I do T, I can, like, throw it out and I don't have to do this work. And then I can get, like, 5 more FPS. So I can get 2005 FPS instead of 2000 FPS. All right. I need to stop caring about this. Okay. It works. It's just a test algorithm. So how do I do this? I have to add 2 new pipelines. Debug models visually. Vertex buff. So we have all of this information. it's in the vertex buffer. And then we just need to like have a graphics pipeline. So like this all the information is there. We just need to draw edges. FS debug, VS debug, yeah. Debug model pipeline. I don't know what it's doing. So, vertex shader, vertex buffer layout, vertex array 0, 1. What's 1? Is that normals? What are you doing? Normal, float. What? Attributes. Where does it actually write this? Uniform as entire binding color color, no, it's 3, it's vector 3. Color model uniforms graphics model owned, get owned. Inverse transpose. Yeah. So this is the uniforms. So it's color? I'm so confused. So I said the vertex layout. Where am I uploading the vertices? 0, 1. Where do it be doing like that? Vertex fragment. Vertex vertices. It's here. Okay, pause normal. It is the normal. Okay. Why am I including the normal? I don't know. Oh, maybe it's to like cull back faces. Okay. I'm doing backface culling. But can't I just do winding? Like this, it doesn't even ever use this. Debug vertex. Yeah, there's no references to normal. There's no references to pause either. What about the shader? What do I do in the shader? Is it a different shader? Shader. Oh god, is the shader over here? Oh my god. Oh my god, the shader's over here. What are you doing, buddy? Why did I leave the shader here? Am I stupid? Alright, vertex, shader, yeah. VS debug, pause normal. Did I just like not care? Let's see, normal transform. So I'm like setting the normals. Result. Oh, am I just reusing this goob? What is this? Debug entity output. What? Why do I result normal debug fragment shader? I just use the color. Are you stupid? Okay. Vertex. It literally does not care. This is like interpolated and everything, and it just doesn't care. How do you draw lines, man? There should be like a enum somewhere that you just draw lines and it just does it like that in the pipeline. pipeline. In the pipe. Graphics, vertex step mode. So let's just like look through these. Vertex step mode, instance. Oh god. Pipeline compilation option. Primitive state. What the hell this is? Describes the state of primitive assembly and rasterization in a render pipeline. Okay. Do you have like goobers that you can construct with? Primitive topology. Aha! Aha! That's it. Boom! Boom! We're drawing lines. Okay. So yeah, this is gonna like look stupid, but what does it look like? It should like outline the yeah yeah. Can you see it? Can you see it? It's like the, yes. Oh, the lines are so small. You can just barely see the lines. Yes. If I like go like this, you can kind of see it. Yes. Okay, how do I make the lines bigger? Polygon mode. Only valid for polygon fill. Okay. Strip. Oh yeah. Front face. Yeah. These are stupid. Okay. So I'm drawing lines. We draw lines. If I draw a point list, it's just not going to be visible. How do you draw big points? WGPU draw thick lines. Please, sir. Yes, this is what I want. VS Code, bunny, render mesh, wireframe, thick. Why is this so complicated? It's freaking JavaScript. This is actually just JavaScript. Okay, so there's got to be a like. Why are you using storage buffers? What the hell? Triangle list, targets, bind group layouts. Dick. Move vertices outward. Wait. Oh no. Are they doing it in the vertex shader? Okay, I want to stop looking at JavaScript. To draw thick lines in the WG, you can do rendering triangles over the thickness of the line. WG does not directly support thick lines. That's fair. Okay. 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 Um. Okay. So basically, I'm gonna have to generate polygons that are thick rather than being able to draw lines. Okay, what does it look like when I draw points? Yeah, you can't even see it. Ah. There should be like a point like you can't even see it. I see it. I see it. It's right there. There's a red pixel right there. I see it. This is the downside of having a 4K monitor. It's literally 1 pixel. Okay. Okay, I think I could actually pursue this. I'm gonna put this as line list, but then with a comment. I am going to have to generate my own polygons. For thick lines. Yep. Yep. That's gonna be extra code. Can you change the shape in the vertex shader? So like, you got the vertices. Can you like generate multiple vertices per vertex? How would how would that work? JavaScript. How to specify a line width? You can't. Tessellator. Drawing lines. GLSL shader. Oh, did not want to click that. This ability is not portable. Oh. VK pipeline restoration, stay creative, align width. Well, I'm gonna put her there. I'll publish this because it's cool. And then I'm gonna go look at the bot files because remove iter tools. So this can actually be done on master branch, please. Yeah. Oh my god. And then it should just work. Nope. There we are. So I can actually just remove iter tools entirely, I think. So read to block. This should probably be a function on to extend a block. Oh geez. Yeah, so this is extend from reader. But like there's also this crap. You can just do this. Extend from timelines. A? Is that really A? Or is that for A? I don't know. Whatever. Yeah, did not realize that this could be done like this. Extend from iter. From block ID iter. It's quite specific. There is self boing 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 self extend from reader take seek data block timelines blocks. Yeah, man. There's no return value. Okay. You good? Expected enum. Oh, I need to say okay. Cringe. Okay. So then down at the bottom here, it becomes mutt block mute. Mutt block equals block default, and then block dot extend from, and then like that. So it's a little bit different. Actually, I can go like this. And then this one goes like this. Watch this. And then we go like offline blocks. None like that. Real-time blocks. None like that. Done. Except, lol. And now there's no iter tools. I can actually just drop the iter tools dependency, but it has to be added back like immediately. Yeah. Drop iter tools dep temporarily xd. Well, that isn't that nice. Did I remove the comment? Yes. Okay. And it should work as well. I require it to work. Strafesnet, Roblox bot file, cargo test release. Wow. Yeah. I don't know why I didn't do this in the first place. That was stupid. Iter tools is actually a pretty nice dependency. It's nice and small. Where is either? Can we like 0? Okay, so who has either? binRW has either, doesn't it? Yeah. Fine. That's nice. One little dependency dropped. What about this function signature? Can I do like 4? Okay. And it doesn't like this, right? Yeah. Okay. We don't need no editor tools. It doesn't, like, basically, if it doesn't work, then the file is malformed. And even if that is, like, fixed, you can still malform files in a way that breaks it. So I think this is okay. I think it's neato. I don't know why I didn't think of that. It's pretty obvious. Right. I'm trying to fix like the error values. Ugh. Can I pop? Nah. I want this as well. That's nice. Yeah. So the error. I don't need this. So like read errors being different. That's like okay. That's a bin.rw error. That is also bin.rw error. So like, but then this is not a bin.rw error. That is an invalid block ID. That this is like the only way it can fail. That's not a bin.rw error. I'm wondering. Right. So this is used. I feel like I should make this a real thing. I would just say like, yeah, that's an error. I guess just for this, then where do I put it? Pub struct invalid block ID semicolon derive debug. And then and then invalid block ID, and then invalid block ID, invalid block ID, and then impl from invalid block ID for error from self invalid block ID value. Yeah. Oh, it didn't actually do anything crazy this time. Yeah, and then what do you want? Needs to implement into error. Oh, in the test. Yeah, of course. So, I think that unwrap is okay for this if I do it this way. Because these are all bin.rw errors. The problem is what's going on? I don't know. I just hear my computer revved up. Is it just not revved up and I'm hallucinating? It's like, should I wrap the error type? What do I do? This is a special kind of error. Invalid block ID. Oof. I think that's not terrible. And then this has the more general error. I could fail in multiple ways. Seek. Take seek. Take seek. So this guy, block info, take seek, IO error. I think I like that better. Where like this has its own error variant. I should implement the error trait. Yeah. Do I want this to be called error? Like I only use it for errors. How does that look like in the function signature? Invalid block ID error. Why does this show up in the function signature? So like invalid block ID, it's pretty obvious that's an error. And like it's literally in the error variant, you know? I don't super like that goes into the function signature. Let me just do ID. So that looks better. So we have this function signature block ID returns invalid block ID. And then the tests are made better as well. So this is add invalid block ID error. I believe that's what's going on here. And then did the test work before and after? Refactor tests. So that's like, I wanna, where is this? They do build. Okay. Yeah. So the problem with this is that you can't name the return type of this without also importing binrw. But I could just do that at a lib level and do like pub use binrw error as binrw error, like that. So now you can name it. So that's the only thing you'll ever see from binrw. Like these things implement the traits, but you never need to call the function yourself. So like if we look at this from reader function, you could import binrw and then do readly args with the header, and that would work. But you don't have to do that. If you want to like integrate it with other things with binrw, then you're working with binrw, then it makes sense. But you never need to name it. I find that annoying in the HTTP crate, how I can't name bytes. Do they re-export it? Am I just being stupid? Am I stupid? Re-export binrw error. So yeah, that just helps with like naming. Maybe that's not the right place to do it. Because then like, okay, binrw result. Because like, yeah, it appears in the function signature like this. Or maybe that is the right place to do it. Because all of them are going to use binrw, so it's like pub use binrw error as binrw error. And then I can just use create binrw error. And then instead of bin result, I have result with binrw error always. And then when you read the function signature, you're like, oh, binrw error? Oh, that's in the module. And you can like find that. I'm thinking like a library user while being a library author. I'm trying to make it nice to use and not like annoying, like, oh, I gotta import binrw now. Re-export binrw error and make it appear in function signatures. bin.rw error. And all the traits are sealed. You don't have to import my dependencies to work with my library. Yeah, man. And then this is like a little bit less cringe. It doesn't return an error that don't matter. It doesn't return an error that doesn't matter for what you're trying to do. Take, seek, IO error. Yeah. So you already have IO error. It's in the standard library, so like, whatever. And then this error is mapped. Error. Take, seek. In this function. Map error, seek, map error, invalid data. Bow. So is that all of the error variants? Invalid, yeah. Block info, invalid block ID. Boom, boom, boom. So that only appears in this function. So this function, error makes sense. All three variants are possible. And then anywhere this is called, it makes sense. All three variants are possible. Invalid data is used many times. Okay. Very nice. Okay, wait. We can actually do better here. Does this appear? No, it's just there. So this is bin.rw error capital B. Let's go. B. Re-export bin.rw error. And then that shows up in here. No, it doesn't, but that's okay. Nice. I don't have from implemented, but that's okay, maybe. I think this is a better interface. So that is still called error. So nothing can go wrong with serialization as long as the timelines are sorted. Interesting. Even if the timelines aren't sorted, it will. Yeah. Even if the timelines aren't sorted, it will return something. It'll just have like kind of like random blocks in random places, but like you fed in invalid data, so get bent. Why don't I explicitly note that timelines had to be information about blocks of data. Oh, wait, you never do this. Okay, well, it's in the block. It's in the block. Block. Segment of event times. Timelines must always be sorted to period. Yeah. Timelines must always be sorted. So just like segments are always sorted. Segment of event timelines. Timelines are always sorted. Explicitly note that lines must be sorted. Okay, so now it's not stupid. It tells you that the timelines need to be sorted. We drop iter tools, we change the tests, we add this error, we do this function. Very good, very good, very good. So then, is this deserialize error? Or is it not? Error. Deserialize. It's a read error, write error. I can just call it error, leave it error, and I'm chilling. And then in the serializer, no. It's just freaking the error, man. And then serialize error, not real. We do not care. Yeah, I do need this test to be like this though. Read all to block. Yeah. Yeah. So give that back. Revert. Revert. And then that's chill. Revert? Right. It's right. So I was like upset about this yesterday. So I dropped this and I squashed this, and then this is not real. And then I rebase on the master. And it's gonna hate me. Gah. Reader X, writer X. Yeah, we can just use both, man. Just take it easy. Oh boy. Tests. Yeah. Serialize all. Use left. Okay, bud. And good. Oh crap. Oh crap. Iter tools. Lol. V0. No, man. Stop changing the test, you idiot. Create V0. Really? Am I like uncreate V0ing? Header timelines. God. Serialize. This is dumb. V0. Just do like that. Okay, what do you want? Yep. Left, right, like that. Continue. All right. Okay, so then origin serializer clippy fixes. Oh boy. Yeah, we totally need that dependency. We can't live without it. Keep going. Clippy fixes. Yeah. So it should just be like fine, and I should be able to run tests, and it should compile, but it might not compile because I meant, oh wow, I made all changes. Wow. Okay. Okay. So there is no such thing as serializer error. This is the only way it can go wrong, and I've re-exported it. And this is well defined, and the other ways of doing it are well defined. Everything's well defined. Very good. Very good. I do like that. Okay, and the tests are nicer. I think I'm just gonna major version, cause like, you know, add serialization. Okay, I'm happy with this. I'm happy with the way that the errors are. That's very nice. I'm happy that you can read out the block with no editor tools as well. That's pretty cool. Cool. I can actually disable the feature by default. Although, is there any Scoobert on the Dubert? If I disable that, no default features. Does it warn? It does warn. So that's for the events. Where's that damn function? There it is. Ugh. So it's used in one spot. I could actually remove it and make a little const. Yeah, I could do that. And I could call it like this. Dot zip. Oop. Event types. So that. And then we go to the old unused function graveyard. Zoink this. Make it go away. Go to the bottom. Go to the top. Event size. Const. Event types. Yeah. Event type 8. Everyone excluding my mother. And then zoink this. And then that's good. Okay, so that gets rid of the goober function. Yeah. And it should opti away. Rid of event type from usize. So now there's no more lints, and we also have to test it with. Yeah, good. Okay. Yes, yes. Minus 18. Okay. I should probably go this order. Okay. Getting closer, getting closer. Okay, so I believe I bash this into Serializer, branch, and it's gone. Bop this, bop. And how's my big boy looking? Big, strong pull request. What's the diff? Okay, so addition, new features to do serialization test. There it is. And then new. Very nice. Yes. Yes. I like. That's clean. What do I call this? Implement Serializer. Huge. I feel ready. I feel good. Yeah, I can just publish it and then publish a new version if it sucks and I made everything bad. Okay, I'm happy about that. Yesterday I was upset about the error types, how I had like a deserialize error and a serialize error, and it was like you couldn't really deal with it, and it was like not well thought out. So I thought it out. Let's go. Is Discord updated yet? Oh. 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 Do I want to do that? Yeah, no, it's fine. It kind of is fine. Please don't. Okay. It's stupid. Discord's stupid. I would love to completely remove Discord from my life. Oh. Merge it now. Actually, wait. It's an optional dependency. It just remains an optional dependency. You just don't need it for decoding anymore. Yeah. Hi. I think it's good. I could just publish 2 versions. It's not a big deal. Yeah. Do it. Okay. 8 with no features. V0.8.0 drop iter tools. And we zoink that. Where is it? There it is. Cargo publish. And then merge this pull request. Merge. Squash. And not ready to be merged. Conflicting. You're lying. Oh, I see. Wait, no. Wait, what? What are you talking about? Oh, I edited that line of code. Okay, I'll do the stupid goober move. Merge. Yeah. Yep. Alright, it's just easier that way. Yeah. Refresh. And 24, very good. Squash. Delete. Squash. Go. Good. Master. Pull. Squash. Boom. We don't want to edit that one. We want to edit this one. 8.1. Boom. V0.8.1 serializer. Implement serializer. Capital I, capital S. No. And then publish that. Okay. Very good. I kind of want to update the stuff. What is it? It's this guy. It's this guy. It's this guy. I wonder if it's gonna pick different version. Let's see. Does it break? I don't think it breaks. It's just like a tiny bit nicer. V0 error. Yeah. Still called error. Yeah. Oh, it went to 8.1. Okay, I actually don't need editor tools on it, so default features equals false. And now we can drop editor tools from there. But it's still a dependency for other things. It's just a needless sort. Stop trying to change Windows, man. Update Roblox bot file again. Yeah. And then the bot cruncher. Bot cruncher. So then I update this to 8.1. And I do need the features because we're doing a round trip test. And I didn't add eek to it. mute data update. Round trip test. So see how I added this dependency? The way I did it now, I don't need to do that. That's why. That's why. Why? So, I already tested this code. But yeah, you can't check equal like that. It's kind of stupid. Why don't I check the lengths? So we do like this, and then we don't need this. We cherry pick this, yoink, and then cherry pick this, yoink, and then good, and then we cannot do this, but that's okay. What about this? Yes, so we need bin or W error from V0 from and then and then the block, the blur. Yeah. Should we do and or not? Why don't we do not? If not equals dot all of them. Yeah, all of them. Grab it. All of them. Yeah. I'm just gonna go like this. So block rt dot input events dot length equals block dot dot length and so if we don't get all of these conditions, can you do this? No. You can do this though, I think. Oh, oh my. Huh. Cool. So all lengths, if all lengths are not equal, then they're not equal. Simple as that. So we also expect this to have dead code. Round trip test. Approximate. So like, yeah, the values could be different, but like, I already tested that. All right, let's run it. This is going to be cool. So here it is. Git pull. Oh, git checkout master. Let's try this again. Nice. And then cargo build release. Downloading one crate. 8.1. And then it builds. And then run it on here. Are you ready to run the bot cruncher? Crunch the bots. 3, 2, 1, go. Go, 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 go. So, okay, what is it doing? It's going to go for a while. So what it's doing is it's reading all of the files. So this is reading the contents of the directory that I inputted. I was like, mount fast bots, one by one, and it turns that into like a pipeline. So for each item in the pipeline, get the path and read the file. And then it prefetches 64 files, reading it into memory. And then the next step is unordered. So if any of the 64 files it's trying to read finishes reading, it passes it into this function, the next stage of the pipeline. And this spawns a new task on a new thread, a real true thread. It reads the file. It writes the file to memory, and then it reads it again. So it reads it, writes it, reads it, and it makes sure that all of the events still exist, and it's like the same file. Maybe I should do like an iter over. It's already running. Yeah, so, and then it runs up to 32 threads, or I guess 16 on my server. And then it accumulates the results. And that's like the printing here is like, it's counting how many files we've done. Looks like we're doing like 3,000 files per second. That's pretty fast. And this is how many times players jumped. So in this accumulate function here, it's adding jumps. So for each sound event, if it's the jump ground sound, if it's generating the jump ground sound in the file, that's a jump. So it counts how many times you jumped in your bot. And this is the total amount for all bots. And the same for the total duration, total hours of bots. This isn't hours, this is in seconds. And then this one, I was wondering how many people are changing settings after they start their run. I'm curious if there's any world records that do this. I expect no. You generally don't pause and change your FOV in the middle of a world record run. There might be some world records with it done just before, but yeah, that's fun. Okay, so there is 1.5 million files. So we're almost a third of the way done. I'll just let this run. I'm going to get some cheese. Cheese. Feel the power. Feel the speed. Decode the files. Then encode them. Then decode them again. I'm just making sure that my library works for every file that's currently in existence. So that there's no... It's kind of like a fuzz test with real data. Integration test, I guess, is more accurate. No way, it's Stranger Things. Somebody at me. Okay. What else can I do? I am very pleased to have published that. I'm very pleased. What is that? Oh, this is the main, the data processing. The library is a bit more polished. A little bit more library-like. Whoa. Oh, takeseek can be turned into a bin RW error. Crazy. I didn't realize that. Cheese. Very nice. Very nice. Whew. So with this, I'm ready to start the bots V2. And in bots V2, everything changes. But also nothing changes. What else can I work on? Did I write anything down? Right. I don't want to work on that. What's the CPU usage for the server? I guess I can just do it like this. Oh, okay. Nice. 6 CPU cores, just under 6 cores, 606%. Of 16 cores. Most of it is IO. How do I like see IO usage? I know there's like IO top. Let's do that. Oh, okay. Surely it's not like Python with 60 dependencies. Yay. Ooh. Operation not permitted. Okay, sudo net admin. I don't care about network. Just do disk. Alright, whatever. It's almost done. It slows down at the end. I don't know why. It like uses more CPU, less IO. I think it's reading at like 3 gigabytes per second in order to read 3,000 files per second. Like, it is really zooming. I have the files written to an SSD. It's very cool. I should also inspect the like sussy file. The blocks are probably normal. But the timestamps would show. It's almost done. You can see this counting up. EA. Oh yeah, it's at 80% CPU usage now. I wonder if that's like kernel stuff. Like if it's nearing the end of the directory and it's like having trouble finding the final unique files or something. Like if the iterator over the directory contents is some sort of like hash map style thing, and it's like doing a bunch of skipping and like filtering. I don't know. I'm just guessing. Hey, it's done. So, wow, yeah. Every single file is successful. All right. I'm going to debug them. Oh. Test, release, deserialize manual, no capture. Ought to do it. Yeah, look at that. So someone messed with the timestamps, and everything still worked, but this is exploit. Wait, 214. That looks like max int, max signed integer. I can do that easy. Const. 214748368. So they're like minus 1,000. 3647. 36. Yeah, so like they edited their timer to add. They sat there for 1,000 years. How long is that actually? Seconds, 2 years. 68 years. They sat there for 68 years. Surely. And then they started b-hopping. They beat them up. What the heck? Oh, I see. That the precision is coming up. I don't feel like designing bot v2 right now. I really should do a bit more work. I'm satisfied with implementing this. It's very nice. It has a serializer. Whew. 300 lines of code. It's not bad. It's pretty old. How old is this comment? November 6th. It's not that old. What does this say? It says December 15th. I would like it if it like kept the old date. Oh well. Very good, very good. Right, there's also unsafe. It's just such a small delete. Delete. I'm just gonna clean up all this. Alright. And I can write that again in 10 seconds. Comp. Today. It's really annoying how it like scrolls up to the top every time. Oh, I guess I could do this. Read headers, yes. This is more debugging. Drop. The deed is done. We don't need it. We don't need it. We don't need it. We don't need it. Round trip test. It's pretty different from this. Wow. Wow. So these are my like pretty recent changes. Yeah, this was the main bug. Oof. Just awesome. Awesome changes. Don't need this. Stream, yes. Yes. Types, common, read into. I did this kind of stuff. Nice, good cleanup. Good tech. That was like this year. Unsafe. Fantastic. I don't feel like I did enough work today, but I'm kind of done. Am I sneezing on my screen? I'll probably do this all week, and I'll like work on the physics, and then work on the bot file thing. It's a good idea. It's a good plan. All right, I'm gonna end the stream. It's interesting lighting. Don't usually see that on the stream. Got a new bot file version. You could go download the code and write your own bot files that are in the Roblox bhop format. But it's not that useful for anyone that's not Roblox bhop. It may become useful to decode the files later, because like next year I want to make a leaderboard website where you can like click on the time and then watch the replay online. That would be really cool. And so you would be able to download the bot files, and then it would make sense to be able to read them. It'd be very cool. Dealing with copyright of like the map images. Ugh. You're using my copyright. Oh my god, bro. I'm pleased. Pleased with the serialize, deserialize the bot files. I'm very pleased that I was able to like run a test over every single file, make sure it always works. Brilliant. Brilliant, brilliant, brilliant. I should be able to make the bots v2, no problem. Yeah. Okay, I'm gonna eat more cheese. Goodbye.